All right, so general psych class, right? We continue on our sort of, you get a little snippet of a bunch of different areas in psychology. So chapter 8 is all about the developmental psychology approach. I'm going to give a very sort of broad overview of what developmental psychology is like. So if you've looked at your schedule, right, the possible spring psychological classes, there's a whole semester that's just developmental psychology. We have different developmental psychology classes that are like, birth to 5 to 8, adolescent psychology. So there's a lot of stuff in each of these subdisciplines. But in this chapter, we're given a very broad introduction to what developmental psychology is all about. So what is it? When you hear developmental psychology, what are you thinking about? Yeah.
I guess just like the different perspectives someone might have, like growing up, like a 14-year-old is different than a 20-year-old.
Okay. Yeah. 14-year-old is very different than a 20-year-old. We'll talk about sort of moral reasoning, and some of the differences in how we approach moral reasoning, and we would expect to see some differences between a 14-year-old and a 20-year-old in the realm of moral reasoning. What else are we talking about? What do you think developmental psychologists look at? Like, what aspects of life? How they grew up. All right. The idea of nurture, the environment. Developmental psychologists, are they only interested in sort of toddler development, infant development? What are they interested in? All right, the whole lifespan. What developmental psychologists often call from conception to the grave. Right? Conception to the grave. What are people like? What happens to people? Okay, so let's look at some of the learning objectives. We'll talk about what are some of the special research designs that are used to study development in people. Okay, so we will revisit the sort of basic experimental design, and then we'll talk about why that design presents a little bit of a problem for developmental psychologists. We'll look at the relationship between heredity and the environment in sort of determining development in people. We'll look at chromosomes, genes, and DNA, like a little bit. We're not going to go into crazy depth DNA stuff. Relax, we're good. And we'll look at how DNA and how chromosomes, genes, and DNA determine a person's characteristics or disorders that we see in people. We'll look at what happens during conception and prenatal development, and what are some prenatal hazards that people can expose the child to. We'll look at what kind of physical changes take place in infancy and into childhood. We'll look at what are the two ways of looking at cognitive development, and how does language develop? What is the autism spectrum disorder? We'll look at how infants and children develop personalities. How do they form relationships with other individuals? What are Erikson's stages of psychosocial development in kids? We'll look at physical and cognitive personality changes that occur in adolescence, including concepts related to morality and Erik's search for identity. For many of you, this is where you're at. That sort of search for identity. Who am I? We'll look at what the physical, cognitive, and personality changes that occur during adulthood and aging. We'll look at the last three psychosocial stages and patterns of parenting that people engage in. We'll look at how psychology explain why it is that aging occurs. We'll look at what are the stages of death and dying. And we'll look at what some of the cross-cultural differences in views of death and dying. All right, so here we go, right? What does it mean to say, to father a child? What does it mean to father a child?
I mean, biologically speaking?
Just answer the question. What does it mean to father a child?
To donate your sperm to someone?
Okay, to donate your sperm to someone? Yeah.
To have harsh rules and discipline.
To have harsh rules and discipline? Okay. For the rest of you, what does it mean to father a child? What does it mean to father a child?
Me?
Yes.
Father a child? I don't know.
It's not an acceptable answer. Why is this hard?
Because everyone has a different opinion of what it is.
To father a child?
I mean, to an extent.
All right, let's move. What does it mean to mother a child?
Like be protected.
What?
Like be protected.
Okay, be protected.
To act as like a female role for a child.
Okay, acts as a female role for a child.
Be there to support them.
Be there to support them. What? Okay, so we've had like 2 answers for one and 3 for the other. Why are you telling me very different things here? For mother or child, it's all about nurturing and being there and supportive, and this is like giving your sperm to somebody. Or what was the other one? Oh, harsh rules and discipline. All right, so being a sperm donor and providing harsh rules and discipline versus being loving, supporting, being there.
Because like men and women have like different roles. Well, like they play different roles to like parenthood. Like like fathers are like more disciplined and mothers are more loving. Like in parenthood, I guess. Well, period.
Says who?
Society.
What?
Society.
Okay, society, right? So you said the word. Let's roll with it. What a role. Let's roll with it. What are roles? R-O-L-E. What is a role?
You mean like gender roles?
Sure.
Okay, well if you want to go with gender roles, like a lot of people.
You're giving me gender roles.
Yeah, well like for gender roles, like a lot of people would associate like the husband or the father in the household to like go out, get a job, support the family, be like the provider. And then the mother, a lot of people would associate the mother with being like the one that stays at home and does like cooking, cleaning, and being the nurturer and the kind one.
Okay.
It's kind of just the part you play, whether it's in somebody's life or in society.
Roles.
Mhm.
Okay. What else? Where do these roles come from? Yeah.
I think it was just like, back in the day, like that, like that's what they did back in the day, and we just followed what they did back in the day now.
Okay.
But like we're starting to become like women are starting to step up and like take the role of male and like go to work and still take care of the child and stuff.
Okay. All right. So we see some change in gender roles. What you're saying.
Yeah.
Okay, but there are still some long-lasting gender roles. Okay. Okay. So your sort of options for employment as a woman, are they different from what was available to your grandma?
Yes.
What was available to grandma? Housewife. Nursing. Secretary. One more. Teacher. Right? What about now? What's open to women?
Almost everything.
Almost everything, right? What's the glass ceiling? Have you heard this phrase? What is it? What's the glass ceiling if you've heard it? Yeah.
It's like an invisible force that makes it so that you can't really progress further than what you want to do.
Okay, very good. So the idea of the glass ceiling is that there's this sort of invisible barrier that has kept women and minorities from being able to sort of pursue particular dreams, goals that they have. When Hillary Clinton was defeated in the 2008 election, part of what she said in her campaign when she sort of ceded over to Barack Obama, she said, we put 17 million cracks in the highest glass ceiling that has existed for women. What was she referring to? What was the 17 million she was referring to?
All the votes she received.
All the votes she received in the Democratic primary, right? Shattering that ceiling. Okay, so the idea of gender roles, right? Very strong, right? Our perceptions of what it means to be a dad and what it means to be a mom. We see cultural differences. Society, socialization, has told us what a dad should be like, has told us what a mom should be like, right? Even if we sort of approach our relationships with a very egalitarian ideal, right? That I'm not going to teach my kids sort of gender role expectations. Might we still do it? We're competing against society at large, right? Little boy falls and skins his knee. What do we say?
Go get your mom. I'm sure, like, your mom will help you.
Oh, okay. All right.
Suck
Mom's
it up.
not here.
You're all right.
Sorry, buddy.
Shake it off.
Suck it up.
Rub some
Suck it
dirt
up.
in it.
Rub some dirt in it, right? Suck it up. Walk it off, right? Little girl falls and skins her knees. What do? Oh, it's all right. It's okay. It's okay for you to cry. It's not okay for your brother to cry. Knock it off. Don't cry. All right. So socialization. we're going to talk about the development of gender, but before we even start, I want you to think about, as we start talking about some of these issues, the power of environment, right? The power of the environment in dictating things like how we perceive ourselves, how I perceive what my role should be like as a dad or as a mom or as a husband or as a wife, right? Roles can be strange for us, but we habituate to them, we adjust to them, and it's easy over time. All right, so looking at developmental psychology, we're talking about human development, right? Everything we do in psychology is the scientific-based approach. So the scientific study of the changes that occur in people as we get older, from conception until death, from conception until the grave. Tell me what the very basic experimental design is. What are the elements of an experimental design? We're done with task 1, Dr. Hackett. I'm out. What are they?
Control and experiment group.
A control group and experimental group? Okay, so we're talking about our independent variable, yes? I'll do it, it's cool. All right, so we have the independent variable, we have the dependent variable, and we have random assignment in 2 conditions, yes? I have a group of individuals. I'm going to randomly assign them either to the control condition or the experimental condition. The independent variable is what is under the control of the researcher. Remember, if we're seeking a cause and effect relationship, we need to run an experiment. So that independent variable, right? We're manipulating something. We randomly assign participants to these conditions. The dependent variable is what we think is going to be impacted by our manipulation, right? Okay, so in developmental psychology, that sort of classic experimental approach doesn't work. If I'm interested in development and I'm interested in age, what's the limitation here?
You can't randomly assign people ages.
Yeah, I can't randomly assign people ages, right? I can't randomly assign some of you to be 20 and some of you to be 80, right? You come in as you are. So this is an issue that developmental psychologists have to deal with. And they're not the only branch of psychology that has sort of limitations when it comes to our ability to manipulate those things that we are interested in. Social psychologists interested in socioeconomic status issues. I can't randomly assign some of you to be wealthy, some of you to be poor. If I'm interested in gender issues, I can't randomly assign some of you to be men and some of you to be women. If I'm interested in race and ethnicity issues, I can't randomly assign some of you to be white and some of you to be black, right? There are some variables that we are interested in that we cannot manipulate. So in the developmental world, age is something that we're interested in. And we have to think of different ways that we can sort of investigate what we are interested in. So something like the longitudinal design is going to work well here. In a longitudinal design, we're studying research participants for a long period of time. So maybe I follow them every 10 years. So I get them when they're entering college at 20. I measure them again when they're 30. I measure them again when they're 40, and they're 50, and they're 60, and they're 70, and they're 80. I follow them for an extended period of time. So longitudinal designs are going to follow a participant or a group of participants for a very extended period of time. Okay? Let me come back to that. Here we go. So tested at year 1. I've got these kids when they're newborns. I get them again 3 years later when they are 4 years old. Now I can look at change. I can look at change in this specific group of kids. So I have kids, the same group of kids at 1 year of age and again at 4 years of age. You with me? So I can look at growth and development in these exact same kids. And I get them again. I get them again 3 years later when they are 7 years old. So now I can look at the actual growth that has, now they're reading and stuff like that. I can look at the actual growth that has occurred in these same kids over time. You with me? So this takes a long time, obviously, right? We have to wait for these kids to develop. So it takes a long time to conduct this type of research. As a possible alternative approach. Okay, sorry, so exact same participants in the longitudinal design, different points in time. But the point is the exact same participants over time, okay? In a cross-sectional design, what I'm going to do is I'm going to have data collection occur at the exact same time. Well, what's going to be different is I'm going to have 1-year-olds, 4-year-olds, and 7-year-olds. The sort of issue here, though, is I have a group of 1-year-olds, I have a group of 4-year-olds, and I have a group of 7-year-olds. These are not the exact same kids. So let's say my data collection is happening right now in 2015. In 2015, I have 1-year-olds, 4-year-olds, and 7-year-olds. This is very different than the longitudinal design, right? In the longitudinal design, I had 1-year-olds, 4-year-olds, and the 7-year-olds. They were the exact same individuals, followed over time. Here I have 3 groups that I've collected data on at the exact same time. They're not the same kids, right? I have 1-year-olds, I have 4-year-olds, and I have 7-year-olds. You with me? So the cross-sectional design has different participants. So unlike the longitudinal design, where it was different points of measurements with the same people, here we have all of our measurements being conducted at the exact same time, but with different participants in each of these groups. Okay, so I can compare and contrast. What do 1-year-olds look like to 4-year-olds? What do 4-year-olds look like to 7-year-olds? Or this sort of jump too, which isn't quite as meaningful. The maybe 1 to 7 comparison. You with me? But what I can't see is the growth and change in the exact same participants. And the longitudinal design, that's what's unique about that, is I can look at the growth in these same kids over time. All right, you with me? So some of the ways that developmental psychologists approach how they study human growth and development, how they think about these things, and how they collect their data. They have to be cognizant, so aware of, the issues associated, some of the limitations associated with the fact that we can't randomly assign the variable that we are interested in. Let me jump back to this real fast. I like this. Come on. Okay, so cross-sectional design, longitudinal, and then the cross-sequence will make a lot of sense now that we talked about. The cross-sectional design, we have these different participants, different ages, right? But we collect this data at one point in time, and what we're able to look at are age-related differences. What are the 7-year-olds able to do that the 4-year-olds are not? What are the 4-year-olds able to do that the 1-year-olds are not? So we have one group, let's say 20-year-olds in 2011. Our other group are 40-year-olds in 2011. And then we can look at 60-year-olds in 2011. Exact same point in time, 3 different groups. We can look at maybe cognitive functioning. What are 20-year-olds really good at that we see decline in the average 60-year-old later in life? Longitudinal design. The exact same participants are studied at various ages. And here we can look at age-related changes in the same individuals. So if we have 20-year-olds in 1971, when we collect data on them again, it's going to be 1991. They're going to be 40 years old. The next time we collect data will be 2011. They're going to be 60 years old. The advantage here for this design, this is a really long time. 40 years this project's been going on. Here we have the exact same individuals. So yes, I can look at changes over time. Here the added benefit is I can look at this person at 20 years old and look at the cognitive limitations they showed at 40. And again, maybe the cognitive limitations at 60. Or maybe there's no change in some of them. You with me? Exact same people over time. In the cross-sequential design, we have different participants of various ages that we compare at several different points in time. So again, we can look at age-related differences and age-related changes. For here, it would be study 1 would be in 2011. We'd have one group of 20-year-olds, one group of 40-year-olds, and again, looking at them when they're 25 and 45. So the cross-sequential design, it combines a little bit of the two of these, but it doesn't have the long-term study approach here. It's going to be a much more truncated period of time. Okay? So we can look at comparisons between this group here. I can make comparisons between these two groups here. I can look at this group and what happened to them 5 years later, and this group and 5 years later. So it has these added benefits, but it doesn't have the sort of longitudinal multiple data points, very long extended period of time that we associate with the longitudinal design. These are nice, so you have to flip through them really fast, and you're like, ah. Okay, with developmental psychology, this developmental approach, we can talk a lot about the nature versus nurture idea. right? So when we talk about nature, we're talking about all of the influence of what we have inherited. So what we've inherited and how it impacts our personality, how it impacts physical growth, our intellectual growth, our social interactions, right? So the role of genetics here, right? What we got or get from mom and dad. When we're talking about nurture, we're talking about the influence of the environment, right? How does the environment, or where we grew up, how does it impact our personality? How does it impact physical growth? How does it impact our intellectual growth or abilities and our social interaction? For the most part, this idea of the nature versus nurture debate doesn't really exist anymore. What do you think people say about nature versus nurture?
It's like a mixture of both.
Okay, good. That is this interaction, right? That it's a mixture between nature and nurture. Behavioral genetics, right? Behavioral genetics, they focus on nature versus nurture. They try to look at, with individuals, what is happening here in terms of the impact of the two. Oh, all right. I'm not going to show Oksana, but I will show you Jeannie because it's amazing. I have to embed these in the PowerPoint because I would never remember if I didn't.
Tonight on Nova, the shocking story of a girl who spent...
Okay, hold on. Okay, so what I'm going to show you is a little bit of a TV program that aired on a little girl they found in the suburbs of Los Angeles, who, when they found her, I think she was around 10 years old or so, maybe a little older, maybe 12. Her parents had essentially tied her to a chair above a toilet, and that's how she's lived her entire life, right? So when they found her, they obviously studied her in great detail to learn a lot about the sort of negative impact of social isolation like this on kids. Okay, hold on. We'll just watch part one.
Tonight on Nova, the shocking story of a girl who spent her childhood locked in a bedroom.
The girl reportedly was still wearing diapers when a social worker discovered the case 2 weeks ago.
Raised in isolation, Jeannie was a wild child, uncivilized, barely able to walk or talk.
The indications are that she was beaten for making noise.
With footage never before seen on television, Nova follows the controversial efforts to unlock the secret of the wild child.
So think about nature versus nurture as they're presenting this story.
Once in a great while, civilized society comes across a wild child. A child who has grown up in severe isolation, with virtually no human contact. This is the story of such a case. The story begins in Los Angeles on November 4th, 1970.
Officials in the Los Angeles suburb of Arcadia have taken custody of a 13-year-old girl, and they say was kept in such isolation by her parents that she never even learned to talk. Her elderly parents have been charged with child abuse.
This is the scene of the crime. A child was locked in a room and tied to a potty chair for most of her life. Completely restrained, she was forced to sit alone day after day and often through the night. She had little to look at and no one to talk to for more than 10 years.
The girl reportedly was uttering infantile noises and still wearing diapers when a A social worker discovered the case 2 weeks ago. The authorities are hoping she still may have a normal learning capacity.
Here was a 13-year-old who seemed like an infant, a girl who would be known as Jeannie. Jeannie was taken to Children's Hospital in Los Angeles, where she immediately won the hearts of doctors and scientists.
She was fragile and beautiful, almost haunting. And so I was pulled, I was very drawn to her, even though I was nervous and had no idea, in many respects, what to expect.
Jeannie was about to test an idea important to science and society, that a nurturing environment could make up for even the most nightmarish of pasts.
If you make up a sentence in your head, or you write it down, and it has, say, 10, 12 words in it, chances are you can listen for the rest of your life for someone else to say the sentence. You can go to the library.
Here at UCLA, Susan Curtis teaches students about a crucial human trait, the ability to learn language.
At the library, and chances are you will never come across that sentence. What I want to do now.
The students begin their study through a famous case.
The case name is Jeannie. This is not this person's real name, but when we think about what a genie is a creature that comes out of a bottle or whatever, but emerges into human society past childhood, and we assume that it really isn't a creature that had a human childhood.
Susan Curtis has a special connection to the story she's telling. 20 years ago, she was asked to join a team working to rehabilitate Jeannie.
I was literally at the right place at the right time. I was a new graduate student interested in language acquisition, unencumbered by family ties or responsibilities, and they asked me if I would be interested.
When Curtis first joined the case, Jeannie had a strange bunny walk and other almost inhuman characteristics. Jeannie constantly spat. She sniffed and clawed. She barely spoke or made any noises.
The indications are that she was beaten for making noise, and consequently had learned basically not to vocalize. And she really didn't vocalize very much at all. When I first met her, she was silent most of the time.
Jeannie also received daily visits at Children's Hospital from James Kent, her psychologist. Kent recalls first meeting his new patient.
I was captivated by her. I was not the last person to be captivated by her. The story, as we began to learn about it, was sort of one of the things, of course, that would reach out and grab you anyway. But she had a personal quality that seemed to elicit rescue fantasies. And this is a group of people who were interested in taking care of kids and who specialized in early childhood, who were going to be sort of powered by rescue fantasies anyway. She reached out and grabbed lots of us.
One of Jeannie's most captivating qualities was the intense way she explored her new environment. Oddly, even strangers who knew nothing about her story seemed to sense her need to do so.
One particularly striking memory of those early months was an absolutely wonderful man who was a butcher. And he never asked her name, he never asked anything about her. They just connected and communicated somehow. And every time we came in, and I know this was so with others as well, he would slide open the little window and hand her something that wasn't wrapped, a bone of some sort, some meat, fish, whatever, and he would allow her to do her thing with it. And to do her thing, what her thing was basically was to explore it tactily, to put it up against her lips and feel it with her lips and touch it almost as if she were blind.
Word of the wild child spread, attracting scientists from all around the country. One of them was Oklahoma psychiatrist Jay Shirley.
When introduced, I extended my hand. She reached out with her fingers and delicately touched my hand and then in a sense, that was it. She had made my acquaintance. She was satisfied for herself about me. But my reaction was I had 1,000 questions immediately. Who, what, how does this come about? Why do I see what I'm seeing?
Shirley was an expert in social isolation. Jeannie was the most extreme case he'd ever seen.
Solitary confinement is diabolically the most severe punishment, and in my experience, really quite dramatic symptoms develop in as little as 15 minutes to an hour, and certainly inside of 2 or 3 days, and try to expand this to 10 years boggles one's mind.
Shirley wanted to assess how well Jeannie had survived her law.
All right. Okay, so we talked a bit about, in the beginning of the class, case studies, right? What is a case study?
Study based on one specific person that
Okay.
you follow for an extended period of time.
All right, so case study, we focus exclusively on one particular person, right? There are things that we can't study, right? We can't socially isolate somebody for 10 years, 13 years, and see what the negative effects are. However, when these cases come about, we have the opportunity to study this person in great detail to learn a lot about some of these effects, right? Have any of you heard about this before? You heard about this? Okay, all right. Not everybody? What do you think?
It's really sad.
It is really sad. It's very sad. What do you think about her ability to learn later? Do you think she was ever able to sort of live a fully, like, average, a normal life? No, right? All right, we'll talk about some of the limitations, what it seems to be like critical points. When things don't happen and we miss these critical points, what happens to people? Okay, so anytime we're going to talk about human development, right, we have to start with sort of the blueprints for how people are to develop. When we talk about and think about things like genetics, all right, the sort of complex material that contains instructions for life itself. Right, so for genetics, we're talking about the science of what it is that we have inherited, right? What we get from our parents. So DNA is that special molecule that contains the genetic material of the organism, of us, right? What contains our genetic material. And you've all seen the double helix before. Okay, a gene is that section of our DNA that has the exact same arrangement of chemical elements. So we talk about what we inherited and the expression of genes. We're talking about dominant and recessive traits here. A dominant trait refers to a gene that actively controls the expression of that particular trait. What is the most common hair color? Brown is a very dominant hair color trait. Yes? How does somebody end up blonde? I mean, like, besides dyeing their hair. Both recessive. Okay, so for dominant gene, if a dominant gene is present, that trait is expressed. Recessive refers to a gene that only influences the expression of a particular trait if it's paired with an identical gene. So, to be blonde, to be blue-eyed, right, you have to have that recessive, both recessive genes. You got a blonde gene from mom, and you got a blonde gene from dad. If you get a brown gene from mom and a blue gene or a blonde gene from dad, what color is your hair likely to be? Brown. If the dominant trait is there, it is the one that becomes expressed. It's fairly complicated. But here we go. PKU is an inherited issue here. Okay, PKU is a disease where there's a buildup of amino acids in somebody's body. They don't break them down, and it can lead to cognitive impairment. Right? And it's genetically based. So here we have mom, who carries the recessive PKU gene. Let's say that it is the small one, right? Dad does not carry any gene here. He does not carry a recessive PKU gene. So, are any of the children going to have PKU? No, because dad doesn't have it. So this child is sort of normal for what that means. They have two dominant genes, one from mom and one from dad. This child has a dominant one. Two dominant. This one has a dominant and a recessive. could these kids have a child that has PKU?
No.
No. What about these two?
Yes.
Okay, how?
They're carriers of the gene.
Alright, so they are carrier. Here we go. Now we have two people who are going to have kids. Both are carriers of a recessive PKU gene. They have, let's say, 4 kids. Okay? This kid has 2 dominant genes. Is PKU an issue for this one? No. Here we have 2 kids who received a dominant and a recessive. Is PKU an issue for these kids? Well, they're not going to experience it, right? But now what do they have the potential? All right, to pass it on, to inherit it, for their children to inherit it as well. Okay, our 4th child receives 2 recessive. What does it mean? They have PKU, right? Our genetic genes, right? Dominant and recessive. We get it from mom and we get it from dad, right? So there's a Mendel box or a Mendel box. You probably did this with peas in school, right? Did you do it with peas? All right, here we go. Mom, let's say big B is brown eyes, little b is blue eyes. Both mom and dad have a dominant gene and a recessive gene. Here we have dad. There's sort of 4 combinations here, right? Browns, blondes. Blue, sorry. Mom, same thing here. So how many of their kids in this sort of theoretical approach here are going to have blue eyes? Which one is it? All right, the one with 2 recessive. Everybody else who has a dominant, that dominant gene, if it is present, is the one that becomes expressed. The recessive trait is only expressed when it's paired with another recessive trait. You with me? Does it make sense? All right, so 75% of the time we'll see this brown eye thing. And then at 25%, they're going to have blue eyes. Okay? Anytime a dominant gene is present, it gets expressed. It's the trait that is expressed. All right, so chromosomes, right? The tightly wound strand of genetic material or DNA. Where do your chromosomes come from?
Half from your mom, half from your dad.
All right, how many from mom, how many from dad? 23. 23 from mom, 23 from dad. Which one determines your sort of sex development?
X and Y.
All right, X and Y is what? What? XY is male. The Y is how I remember. XX? Female, right? You got it. Yeah, it's stupid, but it can help you remember the trait. I know. Okay. So looking at chromosome issues, right? We see chromosome disorders, right? Things like Down syndrome, Klinefelter syndrome, Turner syndrome, and then we see some genetic disorders. PKU, cystic fibrosis, sickle cell anemia, and Tay-Sachs disease are all genetic-based diseases, right? Chromosomes, 23 from mom, 23 from dad. Okay, so looking at what happens with development. Conception is when we have that moment at which a woman becomes pregnant, right? We have the ovum that becomes fertilized. So ovum is the female sex cell, or what typically people refer to as egg. So fertilization is the union of the ovum and sperm. Okay, so the zygote is the cell that results from this unification, right? From the fertilization of the sperm with the ovum. Right? We have the zygote. It's a cell, and it starts to divide into many cells, and eventually it forms the baby. Right? So one cell becomes 2, those 2 become 4, and so on and so on and so on. Okay? Zygote, that cell that results from this uniting. Monozygotic twins and dizygotic twins. So monozygotic twins are our identical twins. They are individuals who came from a single zygote. For some reason, and it's not clearly understood why, this zygote has split. It splits into 2 separate masses of cells, each developing into a separate embryo. These 2 individuals are going to have what? The exact same DNA. Right? The split was one single ovum and one single sperm that split. Okay? So they have the exact same genetic material. They're carbon copies of one another genetically. Dizygonic twins, what we often refer to as fraternal twins. It occurs when we have 2 different eggs that get get fertilized by two different sperm, right? So dizygotic twins have no more genetic similarity than other brothers and sisters, right? The difference is they kicked it in the womb for the same moment in time, right? That's the sort of only thing then that would be unique about fraternal twins. What we see here is a result in the development of two separate zygotes, right? So again, the only thing that's really unique is they share the uterus at the exact same time. So monozygotic twins, one, right? One. Dizygotic twins, mean two, okay? So identical twins, one egg, one ovum, for whatever reason, again, it's not completely well understood, it splits. Fraternal twins, two separate eggs, two separate sperm, no split here, two separate zygotes, right? Who's likely to have fraternal twins? Why do you think we see them so much now? In vitro fertilization. Drugs that people take to increase ovulation, increase chances of getting pregnant, more eggs. In vitro fertilization isn't perfect, right? So they implant a bunch, hoping that some fade, and you end up getting multiple kids sometimes. I'll show this video later. Have you seen the conjoined twins?
The girls?
The girls?
Yeah.
Abby and something?
They're teachers or something.
Yeah, they're teachers now. Yeah. Okay. So conjoined twins. What has happened with conjoined twins? What?
They didn't fully separate.
Okay. Here we go. They didn't fully separate, right? So for conjoined twins, this split that happens with identical twins doesn't happen. The full split itself doesn't happen. So they end up sharing some stuff. So I think Abby and whatever, what's the other one's name? I don't know, whatever. They each control one arm and one leg, right? I think they both have their own stomach and their own lungs, but they're connected from the hip, the pelvis down, right? Okay. All right, right? So something was happening, and this split didn't fully occur. That's how we get the conjoined twins. In the last few years, there was conjoined twins that were born in India.
There's a lot.
In-
Some
Yeah,
were
they
on
were
the top of their heads.
Yeah, I feel
And
like
then a
I've
couple
seen
were like
one or
chest to
two
chest.
ones with the head.
Yeah, I see the chest to
So
chest
many.
ones. Yeah, there's a lot.
I think you might be overestimating the commonness of it.
It's
It may be, it may happen.
It's on
but-
TV all the time.
No,
Yeah.
that's my point. Is that when it does happen, they show it to you over and over and over, and it increases our perception that conjoined twins is a common occurrence. I think, like statistically, so to speak, it's not really that common. But the media has the ability to make these things seem like they're more common than they really are. What's that?
They might show older things that makes it seem more common because it's like showed now.
Right. Yeah.
So it's so weird.
For some of these kids, for some conjoined twins, they've been able to successfully separate them. What's that?
Right here. Saying there's a bunch everywhere.
For some of them, they've been successful in separating them. And some for the two that are the teachers, they're not able to be separated because of what they share. They could never be completely separated. All right. Periods of pregnancy. The germinal period occurs during the first 2 weeks after we've had this fertilization. Here, what happens is the zygote moves down into the uterus and begins to implant itself in the lining of the uterus. The embryo is what it's called when we have this developing organism from 2 weeks to 8 weeks after fertilization, this germinal period. Okay, in the germinal period, the placenta is also starting to form. What's the placenta?
The sac that the baby lives in.
Okay.
Where the baby gets all of its nutrients.
Okay, where the baby gets all of its nutrients from, right? Okay. The embryonic period from about 2 to 8 weeks after fertilization. Oh, wait. All right, 2 to 8 weeks after fertilization. I thought I skipped it. During which the major organs and structures start to develop, right? The organism is starting to develop. We're starting seeing some specialization in what's happening here. The critical periods are times during which we see certain environmental influences that can have a direct impact on the development of the infant. Right? And we talk about teratogen. Teratogens are anything that can have an impact on the child and cause a birth defect. Things like what? Smoking. Drinking. Drugs. Okay. So some other things, right? Rubella virus can cause blindness, deafness, heart defects, and brain damage. Marijuana can create irritability in newborns, nervousness, tremors, and causes the infant to have easily startled and disturbed by things, and oftentimes very difficult to soothe. Cocaine, what cocaine does is it can cause a decreased height, low birth weight in a newborn, respiratory problems, it can cause seizures, learning difficulties in life, and infant is here again difficult to soothe. Alcohol, right? Fetal alcohol syndrome can cause intellectual disability in newborns, delayed growth, facial malformation, learning difficulties, smaller than normal head, right? Associated with the use of alcohol. There's a study that came out recently. It was in the media a lot, reminding women, please don't drink while you're pregnant. What happened was there was a survey that was done, and one of the findings of the survey is that women are drinking a lot more while pregnant than people thought they were. So the medical community came back out and said, please remember not to drink while you're pregnant. There is no safe amount of alcohol to consume while you're pregnant. Okay, nicotine, so smoking can cause miscarriage, low birth weight, stillbirths, short stature, intellectual disability, and learning disabilities in kids. Mercury, it can cause intellectual disability and blindness. So if you've heard don't eat fish, this is where it comes from. Syphilis can cause intellectual disability, deafness, and meningitis. Caffeine can cause miscarriage and low birth weight. Radiation, higher incidence of cancers and physical deformities. High water temperatures, and increased chance of neural tube defects. Right? Teratogen, anything that can impact it. A weird thing. So my kids all go to the dentist on a regular basis, but my middle son has soft teeth, is how the dentist has described it. And he asked my wife, he asked Mandy, did you have the flu while you were pregnant with Colin? She did. And he said they're finding that women who've had the flu while pregnant impacts tooth development in kids. So he's the one that's getting like cavities and stuff like that. And we brush his teeth every night. His teeth are gonna be softer than his brother's. Yeah.
I have a little cousin that has that, like his, like towards the top of his teeth, towards the gums and all this stuff, like they're rotting, but he brushes his teeth like 4 times a day. He actually loves brushing his teeth, and I think his mom might have the same thing too. So I don't know if he got it from like genetics.
Yeah. Weird, right? I never would have thought anything like, having the flu while pregnant, like crazy things, right? But teratogens, anything that can cause birth defects in kids. Right, the fetal period of pregnancy then is the time from about 8 weeks after conception until the birth of the child. Here we see greater refinement in the structure and function of developing organs. Right, so the viability, right? The point at which it's possible for an infant to survive outside of the womb is usually at about 22 to 26 weeks, right? That they're able to care for this child outside of the womb. So here in this fetal period is when we would refer to the child as a fetus, right? That developing organism here. All right, so looking at some of the milestones or the reflexes that kids have when they are born, right? So what can kids do? What are newborns able to do? Yes. Newborns are able to cry. Right? All right, so, but what other reflexes do these kids have? All right, good. So grasping, the startle reflex. My oldest son, he was little, we used to like say that he does touchdowns. So he gets startled and he'd go, and then when they would slowly go down. And you startle him again, make noise. His hands would go up. That sort of startle response. Rooting. What was the rooting reflex all about? They're hungry, right? So they're starting to root around. If you touch a baby's cheek, it will turn towards you, open its mouth, and search for a nipple, right? Ready for to breastfeed. The stepping reflex, right? Seen in kids, and then the sucking reflex. These are sort of the normal reflexes that we see in kids, and things that show that the child has a healthy nervous system. Right? Reflexes that we would expect to see in kids. some of the motor milestones that we'd see. Right here was when a baby is starting to be able to pick its head up, right? So it can raise its head and chest. And typically we see this about 2 to 4 months. The middle one, being able to sort of roll over on their own, right? From about anywhere from 2 to 5 months. Sitting up with support, right? So this kid is sitting up, but if whatever he's leaning on, if you pull that away, this kid's gonna flop down, right? He's able to sit up, but only because he's got this sort of support. Here, this kid looks awesome, by the way, right? He's got some good support there, and he's able to sit up. So typically between 4 to 6 months, we see kids being able to develop this milestone. Sitting up without support, about 6 to 7 months. Crawling from about 7 to 8 months, and walking about anywhere from 8 to 18 months, right? So there's a lot of, not a lot, but there's leeway when we would typically expect some of these milestones to be seen in kids. My sister-in-law is her PhD is in biochemistry, and she works for Amgen Pharmaceuticals in Southern California. But she works with a woman who heard that if you're a child, delayed walking kids are often very smart kids, right? This is bad. This is probably bad science and meaningless. But the woman was pushing her kid down when her kid tried to walk. Like to prevent him from walking, because she heard the older they are when they start walking, these are really smart kids. Like, so she's trying to prevent her kid from walking. This is like bad science stuff, right? Don't latch on to these ideas, right? Crazy. Okay, so some of the development we see. 4 critical areas of adjustment in the newborn. We see things related to respiration, right? Child now has to start breathing on their own. Digestion issues, right? The child now needs some digestive function. This can be kind of slow to develop, which is good for when we have fat babies. Right? That baby fat is good because it gives the digestive system time to start working. Circulation is starting now kind of on its own. It's breaking that umbilical cord. Temperature regulation here, right? Again, we see these sort of innate reflexes in kids. Looking at the senses. The senses, except for vision, are fairly well developed at birth. Right? For vision, it tends to sort of happen a little bit later. And part of what's going on with vision is that rods and cones aren't fully developed. Kids are seeing in black and white, and the muscles around the lenses need to develop as well. So most infants aren't able to see very far in front of their face. Right? They're able to see what's very close, about 7 to 10 inches, which is good for like the breastfeeding baby, right? That distance. What is the breastfeeding baby able to do? See mom, right? They're able to see their mom. Their sense of smell is pretty good here as well. Sense of smell. It doesn't take long for a newborn to recognize the smell of its mother's milk, right? It can tell what is my mom's milk versus other milk just by sense of smell. Newborns are amazing, right? There's a cognitive psychologist who said one of the worst ideas in psychology ever is the idea that we are born as blank slates. He said, clearly, we are not born as blank slates. Look at what newborn babies are able to do right away, right? The amazing things that they are able to do. All right. We see a lot of synaptic pruning, right? Unused synaptic connections in nerve cells are going to be cleared away. What they're trying to do is make way for functioning connections in cells, right? A lot of growth in kids. Okay, let's talk, not long, but let's talk a little bit about immunizations. Okay. Immunizations, right, are far less dangerous than the diseases they are designed to prevent. What has happened with immunizations and vaccinations is in the late 90s.
People say it's linked to autism, and that's why they don't like to immunize their children anymore.
What do you think? Is there a connection there? No. All right, in the 1990s,